The next application type problem we're going to do is a mixture problem. They're very formulaic in that they all basically work the same. It's just that the scenarios are different. So let's look at two different ones. The first one says how many ounces each of 5% hydrochloric acid and 20% hydrochloric acid must be combined to get 10 ounces of solution that is 12.5% hydrochloric acid. And I realize that it's a lot of words and you get lost in the words. But we're comparing two things. The 5% hydrochloric acid, we're going to let that be X, and the 20% hydrochloric acid, which is Y, and those are amounts because it says how many ounces of each. Well, amounts go inside of something. So in our picture, which you always want to draw, I'm going to put X here and Y here. This is the amount of 5%. This is the amount of 20%, and I know that my total amount given to me in the problem will be 10. So those amounts are inside my containers, and that's my first equation of my system. X plus Y equals 10. The next equation of my system is called the value equation, and it's exactly the same as the amount equation, but you put the labels or the values underneath each amount container. So 5%, because it's a percent, we have to write it as a decimal, is 0.05. 20% as a decimal is 0.2, and 12.5% as a decimal is 0.125. So my value equation is the same as my amount equation, X plus Y equals 10, but it has the values that go with each piece in front. Now you have the option that you have your two equations of either using substitution or elimination. I like to use substitution on these because it's so easy to take the amount equation and subtract an X from both sides and get a very simple substitution equation that will work well because it's been solved for Y. And I'm going to put that in right here. So that's going to give me 0.05x plus 0.2, take out the Y, put in your substitution, equals multiply 0.125 times 10, and you get 1.25. Now we distribute 0.05x plus 2, 0.2 times 10, minus 0.2x equals 1.25. Combine like terms and you get negative 0.15x plus 2 equals 1.25. We're going to subtract a 2 from both sides. You get negative 0.15x equals negative 0.75. Now we divide by negative 0.15 on both sides. Negative divided by negative is a positive, and I get X equals 5 ounces of 5% hydrochloric acid. Because this was the substitution method, I go back to my substitution equation, plug in what I found for X to find Y. In this case, the X and the Y amount just happen to be, oops, that's supposed to be 20, the same amount. That's 5 ounces of each, which makes 10 ounces total. Now let's do another one because I want you to see the same exact process repeated, but this time instead of percents, we have dollar amounts, but same process. So number 2 says a grocer has some $4 per pound coffee and some $8 per pound coffee that she will mix to make 50 pounds of $5.60 per pound coffee. How many pounds of each should be used? So we're going to say let X equal the amount of $4 coffee and Y equal the amount of $8 coffee. As the last problem, we put the amounts inside the containers, X and Y, and the total here is going to be 50 in the big bag. The values go underneath. $4 coffee and $8 coffee is going to give us $5.60 coffee. Our first equation is our amount equation, x plus y equals 50. Our second equation is our value equation. Remember, it's the same as the first equation, x plus y equals 50, but there are values, I didn't leave enough space there, in front of the amounts. Now I'm going to take x plus y equals 50, and just like I did in example 1, I'm going to solve it for y, and I'm going to use that as my substitution equation. And I'm going to put that into this equation here. So I have 4x plus 8 times 50 minus x equals 5.6 times 50 is 280. So let's distribute 4x plus 400 minus 8x equals 280. Combine like terms, negative 4x plus 400 equals 280. Subtract a 400, and let's move this up here because I'm out of space. Negative 4x equals negative 120. We divide by negative 4, and we get x equals 30 pounds of the $4 coffee. Now I want to know how much of the $8 coffee. I go back to my substitution equation and I say y equals 50 minus what I found for x. So y equals 20 pounds of $8 coffee. Again, using the idea of having two equations, an amount equation and a value. And whatever that amount equation is, you're going to have your value equation be the same thing, except that it has the dollars or the percents in front of it.